Now we want to talk about how we're going to turn our voltage measurement into a corresponding temperature measurement, because ultimately what we want on the screen is the temperature of the thermistor over and over and over again. So how do we relate the voltage to a temperature? What we do is we take the Arduino with its analog input connected, A0 connected to the resistor to 5 volts and the thermistor down here, and we basically put the Arduino, well, we connect a temperature probe very close to the thermistor so that they're both experiencing the same temperature. That probe is connected to a data logger, okay? And the data logger basically reads, and you can set it to constantly read the temperature on the thermistor. In the meantime, hopefully we've got the wireless sorted out at that stage, and your Arduino is wirelessly printing to the screen, because you're running the loop, it is wirelessly printing to the screen constantly the voltage on A0. You then put this system maybe into a fridge at a freezer at -4 degrees Celsius or something. The temperature probe will tell you what the actual reading is, and let it get down to a low enough temperature, say -4 degrees. Take it out of the fridge or the freezer, and so we'll remove the fridge or the freezer, okay, and start to observe the readings on both the screen and the data logger. Because now you have a reading on the data logger that represents temperature, and you have a reading on the screen that represents the voltage that corresponds to that temperature. So you need a person here with a piece of paper, and they are going to record voltage and temperature. So they're going to write it down, okay? So this person will shout out maybe a reading for the temperature, maybe -4 degrees. This person will shout out a corresponding voltage. It might be, I'm making this up completely, 2 volts. This person might then go 0 degrees. Now remember, as the temperature goes up, the voltage should go down. So this person might say 1.8 volts. 1 degree or 5 degrees. 5 degrees, so maybe 1.2 volts. And so on. What you can then do is, we would ideally like to go from about -4 degrees to about 25 degrees or 30 degrees, maybe 30 degrees. Depends on what we think our can is going to be exposed to. Now, to get it up to 30, that's above room temperature. So what we might need to do is, once it starts to kind of read the same reading, which is the room temperature, we're going to need to heat this thermistor up a bit. So we could put a hairdryer on it, okay? So if we put a hairdryer slowly on it, we can raise its temperature so that we can get up to 30 degrees on the thermistor, and therefore we'll get the corresponding readings for 30 degrees, okay? So at that stage, we can now take our data, turn everything off effectively, take our data and plot a graph. And the graph will be, now we don't need to physically plot it. The good news is that Excel will plot the graph for you. So you just put these, and I'll show you how to do that, into Excel, and you can tell Excel to plot a graph. Now ideally you want temperature on the y-axis and voltage on the x-axis. Okay, and what you should get is some sort of a graph. It doesn't have to look exactly like that at all, but basically it will show that as the voltage increases, the temperature decreases, or as the temperature decreases, the voltage increases. Okay, because remember what we said, that's the way it works. When the temperature is high, the resistance of the thermistor is low, and hence the output voltage is low. Check the first video if you can't remember. Now, Excel won't just print the graph or plot the graph. It will very nicely give you the relationship between your y and your x. So it will come up with a formula that might be something like t is equal to minus 2v squared plus v plus 8. Okay, it just might be that. So it will try to get the best formula it can, and it will give you a number to represent how accurate that formula is. So you're looking for a good accuracy on the formula, but I'll tell you about that, okay? So say you get your formula from Excel. That means you now know how to convert your voltage reading into a temperature reading. So for example, you might now say get the Arduino and put the program into the Arduino, add a line to the program of the Arduino saying, you currently remember have in a box called voltage in the Arduino, you have the voltage value. So what you want now is to tell the Arduino, in a new box called temp, I want you to take the value that's in the voltage, I want you to square it, multiply it by -2, then I want you to add it to itself, and then I want you to add 8. And when you're finished doing all of that, I want you to put the answer in here. And then, instead of printing what's in voltage to the screen, you can change your computer code and tell it to print what's in the temp box to the screen. So now, on your computer, you are basically going to have a series of temperature readings that correspond to the temperature of the probe and of the thermistor. Okay, and if you can now run your program, and you should see the voltage, or you should no longer see the voltage coming up. You should see a temperature, and to check that it's working, you can rub the thermistor on the surface to make it hot. And as you make the thermistor hotter, okay, you should see the temperature going up. So you should see the effect of you having rubbed the thermistor in the results that are being printed in a loop to the screen constantly. So very quickly, in terms of changing the program, basically what you need to do is you need to add in the line float, because the temperature value is going to be a decimal. So float temp, that means in a box called temp that's going to contain a number that is a decimal, I want you to put the value that's in voltage multiplied by the value that's in voltage. That's how you square it. Bracket, now you want to tell it, you want to multiply that, multiply that by -2 in this case. I'm going to continue down here, plus voltage, because you want to add it to itself again, plus 8. So now you've told it, take what's in voltage, multiply it by itself, then multiply the answer by -2, then add the value that's in voltage again, and then add 8. And all of that goes into a box called temp. Then you can remove the line that says serial print line voltage, and instead add the line serial print line temp, because now you want to go out to the screen the value that's in the box called temp. Okay, so hopefully that explains to you how you get the temperature out to your screen.